This is lecture 30. So in the last class we have seen what is the effect of the principle of continuity on coefficient of coupling, that is if k is equal to 1, then transformer will act as a perfect transformer, and in that situation the principle of continuity will not satisfy, and the order of the perfect transformer was equal to 1 as it was a degenerative case, whereas when k is less than 1 then it is non-ideal, non-perfect transformer, and in that situation the principle of continuity will satisfy and our principle of continuity is valid, and the order of that kind of transformer or that kind of mutually coupled coil was 2. Okay, now in this we will solve some numerical examples on the same coupled coils. So let us start with, so first example is, suppose I have the resistor connected with inductor. This is coil 1 and I'll put it some numbers. So this is 3 ohm, 1 Henry, and in the second coil it is, this consists of resistor with some value and short circuit it. So this value is 8 ohm, this is 2 Henry. Okay, and switch it and apply the 6 volt by switching this way, and these are my dots conventions, and mutual inductance is 1 Henry. Okay, and suppose this is my I1 and this is my I2. Now what I have to do, I have to find out what is my I1 of t and what is my I2 of t. Okay, I2 of t. Okay, let me write it properly. I2 of t. Okay, so let us first write again. Let me assume that the switch was open for a long time, so inductors are relaxed. So I1 0 positive, I1 0 negative, I2 0 negative. These are 0, and it is coefficient of coupling is obviously less than 1. So that's why it is also equal to I2 0 positive and I2 0 negative. Sorry, I2 0 positive and I1 0 positive, these are also 0. Okay, so suppose let me write the equation for coil 1. So this is 6 will be equal to R1 I1. So R1 is 3 I1 plus L1 is 1 Henry, so it is 1 di1 by dt plus the mutual EMF due to mutual inductance, it is also 1. So it is simple 1 di2 by dt. So this is equation number 1, and for coil 2 I can write as 0, which is R2 I2 and R value is R8. So 8 I2 plus L2 di2 by dt, so which is 2 di2 by dt plus EMF due to mutual inductance, which is 1 into di1 by dt. Now I have two equations and I know how to solve the two equations as already we have taken it. Okay. So let us solve it quickly, and let me solve it by the use of our operator, that is P, which was the ddt. We have taken it, just such kind of problems while we have seen the solution of differential equation. Okay, so let me write it quickly or solve it quickly. So first let me write in the operator. So 6 will be pi1 plus 3i1 plus pi2, and this is 0, which is equal to pi1 plus 8i2 plus 2pi2, where p is the operator which is ddt. Okay, then write it into matrix form. So it is 6 0. So I1 is p plus 3, then I2 is p, and here I1 is p, I2 is 2p plus 8 into I1 and I2. This is the vector. Okay. Now first let me know what are the roots. So find out the characteristic equation. So for characteristic equation, it is determinant of p plus 3p, p 2p plus 8. So it will be p plus 3 to p plus 8 minus p square. If you solve, you will get p square plus 14p plus 24, that is 0. And this way there are two roots. One root is at p1 is equal to minus 2 and second root is at p2 is equal to minus 12. Now I know that okay, I have to write the solution. So it is consists of the complementary as well. Forcing function is also there. So I can write the equations. That is I1 of t will be equal to k1 e raised to p1t plus k2 e raised to p2t. This will be complementary solution plus particular solution ip1 of t. Then I2 of t, it is k3 e raised to p1t plus k4 e raised to p2t plus ip2 of t. That is, this is the solution due to particular or forcing function. Okay. Now first let me find out what is the forcing response or the particular solution. So first let me calculate ip1 of t. To get it this, what is the equation? I1 was p plus 3 I1 plus pi2, not I1, p plus 3 I1 plus pi2, which was equal to 6. So that you can write into exponential form as I want to get in the particular solution. So it will be 6 into e raised to 0t. So this will be, say, n is equal to 6, and what is the value of beta? Power of it is 0. Okay. And for next equation, that was pi1 plus 2p plus 8i2, which was 0. So there is forcing function is not there. So okay, now my life is simpler. Again only one in one equation only there is a forcing function. So obviously I have to calculate ip1 of t. So to calculate ip1 of t, what is it? Whatever the magnitude of this, that is 6. Let me call it as n multiplied with the cofactor, and that has to be evaluated at beta, and your determinant which is to be evaluated at beta. Okay. So let me evaluate delta p at p is equal to beta. So first let me write p plus 3 p, p 2 p plus, and this I have to evaluate at p is equal to beta, and what is beta? Beta is 0 in our case. So it is 3008. Okay. So what is the determinant? 24, and I would like to get it delta 1, that is cofactor. As already we seen it, so I will directly write now. So delta 1 will be, for this is 8. Okay. So your particular solution ip1 of t will be n into delta 1 is 8 divided by delta is 24, and n is 6. So it will be 3 2. So it is 2 ampere. Okay. So particular solution is 2 ampere. Now I will write I1 of t is k1 e raised to minus 2t plus k2 e raised to minus 12t plus 2, and what is solution for I2 of t? It is k3 e raised to minus 2t plus k4 e raised to minus 12t. Now I would like to get it to compute k1, k2, k3 and k4. I need initial conditions, and I know I1 0 positive, I2 0 positive are 0. Okay. So let me evaluate this at first t is equal to 0. So what was our original equation that which we have written for 2 coils? 6 was I1 dash of t plus 3I1 plus I2 dash of t. This was equation 1, which was second was 0 I1 dash of t plus 8 I2 plus 2 I2 dash of t. So this let me evaluate at t is equal to 0. So it will be 6 will be equal to I1 dash of 0 positive plus 3 I1 0 positive, but I1 0 positive is 0. So this will vanish to only I2 dash of 0 positive, and from here 0 which is equal to I1 dash of 0 positive plus 8 I2 0 positive is also 0. So this will also vanish, only what it will remain 2 I2 dash of 0 positive, and I can solve this using simultaneous equation. So with that I will get it I2 dash of 0 positive is minus 6 ampere. Okay, and if you put it in this equation, I1 dash of 0 positive will be 12 ampere. Okay, so now what I got it, I1 of 0 positive is K1 plus K2 plus 2, and I2 of 0 positive is K3 plus K4. I know I1 0 positive and I2 0 positive. From that I will get it two equations. Okay, and I should know what is my I1 dash of t and I2 dash of t. So I1 dash of t will be minus 2 K1 e raised to minus 2t minus 12 K2 e raised to minus 12t. I2 dash of t will be same minus 2 K3 e raised to minus 2t minus 12 K4 e raised to minus 12t, and this evaluated t is equal to 0 positive. So it will be I1 dash of 0 positive will be minus 2K1 minus 12K2, and I2 dash of 0 positive will be minus 2K3 minus 12K4. Okay, and I1 dash of 0 positive which we have calculated as 12. So this is 12 and this is minus 6. Now I know the four equations, four unknowns, so I can solve it very quickly. Now here my solution is I1 dash I2 dash, if I substitute, and this will be obviously 0, this is 0, this is 0. So if you solve, I got it, K1 is minus 6 upon 5, K2 is minus 4 upon 5, K3 is minus 3 upon 5, and K4 is 3 by 5. Okay, so now my I1 of t will be 2 minus 6 upon 5 e raised to minus 2t minus 4 upon 5 e raised to minus 12t, and your I2 of t will be minus 3 upon 5 e raised to minus 2t plus 3 by 5 e raised to minus 12t. Okay, so observe that this will be equal and opposite. Okay, now if you want to check it out for the physical, using physical inspection also, because at t is equal to 0 I should know what should be the my value of I1 0, it has to be 0. So if you put it 0, what if you evaluate this I1 t and I2 t at 0, it will be 2 minus 6 up minus 5 minus 4 upon 5. So this will be 5 10 yards. So this is 0, and second equation is also I2 0 will be minus 3 by 5 plus 3 by 5, so 0. Okay, so it satisfies according to our physical inspection. Okay, this way you can solve it. Now next example, example 2. Suppose I have the primary coil, now it is connected through current generator, say Ig of t, and this is coil 1, this is coil 2, which is, let's say, secondary is 1. Okay, instead of I, let me call IST. Okay, then say this are my dots. Oh, not here, suppose now opposite dots here. say this is 2 Henry, this is 4 Henry, and suppose mutual inductance is 3 Henry. Okay, and this is my V of t. Okay, and seen that now suppose it is open. Previously we have seen we have seen that secondary coil was shorted. Now it is open, and suppose now Is of t is given. Is of t is 8 into e raised to minus 2t into u of t. Okay, and question is, let me find out what is v of t. Okay, to get it, let me start with the coil 1. So what is our equation? V1 was L1 di1 by dt plus m di2 by dt according to our conventions. Okay, now if this is the equation for coil 1, what I observe that this is my I2, right? This is my I1 and this is my I2. Okay, and what it is open, so what will happen with I2? I2 will be 0, so this will be 0. Okay, so what will be V1 will be L1 I1 dash. Okay, now let us talk for this is V2. Okay, now let us talk for second coil V2. So V2, but it is a negative as per the polarity what has been marked. So now I will write minus V2 will be L2 I2 dash plus M I1 dash. Okay, and again I know this is open circuit, that's why I2 0, so this will be vanished. So it will be minus V2 M I1 dash, or V2 of t will be equal to minus M I1 dash of t. Okay, so V2 is minus M I1 dash. And what is I1 dash? I1 dash is nothing but Is, and I observe that again it is this is my I1 dash which we have defined our convention, but Is is opposing I1, so then I1 dash will be, I can consider a negative, right? This is minus M and it will be minus I1 dash. Okay, so which will be M I1 dash, and I1 I know that it is 8 into e raised to minus 2t into u of t, so it is M into d dt of 8 into e raised to minus 2t, and M is how much? It is 3, and differentiation of 8 e raised to minus 2t, so it will be minus 2, so this is minus 2 into 8 e raised to minus 2t, and it will be minus 48 e raised to minus 2t. What is it? This much volts. Okay, so your V2 of t will be minus 48 e raised to minus 2t volts. Okay, that way we can solve. Now suppose next example, say I have the coupling like this, I have the transformer this way, suppose. They have coupled like this, dots are marked this way, then it is connected with source voltage plus minus say Vs of t, then to this it is connected to say resistor R. Okay, and this is my V2 of t. Dots are like this, so this is my I1, this is my I2, and this will be my mutual coupling M. Okay, so find out what is my V2 of t. Okay, so it is simple, and Vs is say your some constant in, so any number you can put, V volts or V1 volts or whatever it is. Okay, So first write for the primary, what was the equation? V1 of t is equal to V1 of t is equal to L1 di1 by dt plus mutual inductance M di2 by dt. What was for V2 of t? It is L2 di2 by dt plus M di1 by dt. Okay. Now I will solve using the Laplace transform. Okay. So let me talk in terms of Laplace now. So find out the Laplace transform. So it will be V1 of S will be L1S I1 of S. Now I'll assume that all the initial conditions are 0. So I1 0 negative, I2 0 negative, all are 0. So L1S plus MS I2 of S. Similarly, what is V2 of S? V2 of S is L2S I2 of S plus M S I1 of S. Okay, and again I can write the equation for V2 of t in terms of R also. So what I can say, V2 of S will be R into I2 of S. But here according to polarities, current should flow from positive to negative, but it is flowing this way. That's why what I can write here, minus V2 of S will be equal to R into I2 of S, as current going from negative to positive direction. Okay, fine, this is done. Now what I have to obtain? I have to obtain the V2 of t, correct? So V2 of S I have obtained, which is minus R into I2 of S, and I need I2 of S. So how can I obtain I2 of S? That we have to see it now. Okay. So what is V2 of S? Minus R I2 of S. I'll substitute in this particular equation, which is for second coil. So V2 of S is minus R I2 of S, which is L2S I2 of S plus MS I1 of S. Okay. Now I can write for I2 of S, which will be minus R plus SL2 I2 of S will be MS I1 of S. So now I can write I2 of S in terms of I1 of S, which is minus SM over R plus L2S into I1 of S. Okay. And what is my V1 of S? V1 of S is L1S I1 of S plus M I2 of S. I2 of S is nothing but this minus SM over R plus L2S into I1 of S. Okay, and now I can write for I1 of S. So I'll take it I1 of S common, so it comes out to be R into R, this multiplied with this, so it will be R L1 R L1S plus L1 L2S square minus M square S, yeah, it is S, it was MS into I1 of S, yeah. So M square S square over R plus L2S into I1 of S. Okay, and then what can be done? This I1 of S I can write in terms of V1 of S, which will be R plus L2S into V1 of S over this will be now L1 L2 minus M square S square plus R L1S. I got it this, and now V2 of S, basically I want to obtain it, so V2 of S is minus R into I2 of S, fine, and I2 of S we obtained this way, so minus r I2 of s is r L1s plus L1 L2 s square minus s square m square over r L2 r plus L2s into I1 of s is nothing but this. So I substitute r plus L2s over L1 L2 minus m square s square plus r L1s into V1 of s. Okay, and what is V1? V1 of s is some V1 volt, V1 by s, some constant by s I can write. So this will be cancelled. Okay, and if you simplify it, V2 of s will come as r m v over L1 L2 minus m square into 1 over this V1 of s is something V by s. Okay, V volts. So is 1 over s into s plus r L1 over L1 L2 minus m square. Okay, if you simplify, you will get it this. Now what next? I will go with the partial fraction, so it will be RMV over L1 L2 minus m square a upon s plus b upon this root s plus RL1 over L1 L2 minus m square. To compute a and b, you know how to do that. So now I will write RMV upon L1 L2 minus m square into L1 L2 minus m square over R L1, and this will be 1 over s minus 1 over s plus RL1 over L1 L2 minus m square. So this R will cancel, so it will be m into v over L1, Laplace inverse of 1 by s is 1 minus e raised to minus RL1 over L1 L2 minus m square into u of t. Okay, so if we apply input, and that input is a step input, for example, so what we'll get it exponentially increasing form with some time constant. And why with some time constant? Because of the energy storage element, that is the inductor present over here. So if I would like to draw the graph, so what is the input? Input is my step input, and this is v1 of t, and what will be v2 of t? I'll get it this. Okay, so this will be my v2 of t. So this way we can solve any kind of circuit which involve the mutually coupled circuit. Then last bit on it, just I'll quickly tell you what is the energy stored in coupled coil. Energy stored in coupled coil can be calculated as W of t, where I will take M1 2, M2 1 is equal to M. Okay, so this is the case, then my energy stored will be half L1 I1 square for first coil plus half L2 I2 square for second, and it will be M I1 into I2 due to the mutual inductance. So here observe that there are three ways the energy can be stored. Where first energy stored in first inductor, then energy stored in second inductor, and also energy stored in mutual form. Okay, so this also I can write as 2 into W of t, which will be L1 I1 square plus 2m I1 I2 plus L2 I2 square. Now here just I would like to play something in order to make out something interesting sort of constant. So this let me do some square form. So for that let me write L1 I1 plus m upon L1 I2 its square. I want to convert this into the form of this. So what will be this is I1 square plus 2 I1 I2 m over L1 plus I2 square into m square L1 square. Okay. So to get it this, let me write this is 2 into W of t. Okay. This basically I want to obtain it. I want to get it. So my original is, what was my original equation is this L1 I1 square, okay, plus 2m I1 I2, this also I got it, plus what can be done, this factor can be added and subtracted. So m square over L1 square I2 square minus m square over L1 I2 square L1 I2 square plus what is the remaining, this is L2 I2 square. Okay, so this I can write as L1 I1 plus M L1 I2 square plus L2 minus what will be M square over L1 into I2 square. Okay, now what again I want to say that L1 L2 minus M square, something I want to get it. So to obtain this, let me assume this is 0 quantity, and when this first term will be 0, when I1 will be M upon L1 into I2. Okay, so this is the case, and if this is the condition, at that time what I will get it, the energy stored as 2 into W of t will be equal to L1 L2 minus M square upon L1, which is where I am interested in, this I2 square. Okay, and we know that L1 L2 minus M square. Okay, so what can be concluded from this, from this equation? We observe that transformer basically the passive element. Okay, so energy stored in transformer has to be always positive. Okay, so if I look this equation I2 square, so this will be always positive, and energy has to be positive. In order to do, or in order to have the energy to be positive, what should be the constraint? Constraint should be L1 L2 minus M square has to be greater than 0. Okay, means what? L1 L2 has to be greater than M square, means what? M has to be, what it should be, the less than the geometric mean of the product of two self inductances. Okay, means what? M has to be greater than 0 and has to be less than L1 L2. So what I want to conclude from this is that when you are designing anything, so you cannot arbitrarily select the value of M. Selection of M always has to be greater than 0 and always has to be less than that of the geometric mean of the product of the two self inductances. Okay. So this is the reason I have taken this form, and this will be applicable only when the ratio of I1 I2 will be the negative of M upon L1. Okay, or I1 is equal to minus M upon L1 into I2. That way also I can say it. Okay, so this way the energy can be stored, and hence the energy has to be positive, and for that reason L1 L2 minus M square has to be greater than 0 always. Okay, so with this I stop here. From the next class we will see the new topic, that is regarding the network theorem. So next class we will see the different network theorems which we can use for the network analysis. Thank you very much.